Good morning, everyone. I hope everyone is enjoying the summit so far. It's so wonderful to be back on stage at this year's OCP Summit and see such a fantastic audience. When it comes to building the Microsoft Cloud, our work to standardize design for systems, board, racks, and other parts of the data center infrastructure is paramount to facilitating forward progress and innovation across the computing industry. We joined Open Compute Foundation back in 2014 and have since then made a number of contributions from rack and server architecture, the Sonic network operating system, security, liquid immersion, and many others. Our belief is that by working with the open compute system ecosystem, we can bring standardization, consistency, and interoperability to Azure customers. Our goal with such innovations, collaboration, and contribution is to ensure we are providing Azure customers an environment where they are operating reliable applications in the most trusted cloud, and that we are powering sustainable transformation. We are now entering a new era of transformation in the cloud. It is an era where security is not just about securing a server, storage, device, or network. It is an era we are calling confidential compute, where we, as a trusted cloud provider, enable securing our customers' data while processing it. This means that we have to enable our customers to be the only ones that hold their keys to their data, processing this data in such a way in hardware-based trusted environment where even administrators or someone with physical access cannot see it unencrypted. Microsoft Azure is a leader in cloud security and privacy, offering a broad range of confidential computing services to help organizations run their many workloads and keep businesses and customer data private and advanced levels of security. As the demand for confidential computing grows from cloud to edge, so do the requirements for consistency and transparency of many security mechanisms that protect all the various workloads. With the rise of edge computing, the resultant growth in the exposed attack surface also presents a need for stronger physical security solutions. In this context, there is an increased need for greater transparency in the infrastructure that underpins these technologies and upholds hardware security promises. Now, as we step forward in this new era of confidential compute, there's an imminent need for building a root of trust into silicon, and it is a journey that requires deep collaboration. As my esteemed colleague earlier, Partha, announced, today we are jointly announcing Calyptra, an open-source silicon root of trust that produces cryptographic proofs around the hardware protections in place for confidential workloads. Designed with security experts and industry leaders in confidential computing across AMD, Google, Microsoft, and NVIDIA, Calyptra is a forward-looking approach casting greater transparency into hardware security. I will now invite Brian Kelly, partner architect at Microsoft and one of the key architects of Calyptra, to talk you through this joint contribution in a bit more detail.
Good morning, Zaid. Thank you. Good morning. I hope you're having a wonderful summit. I'm going to talk a little bit about Calyptra. So Calyptra is an open source root of trust in the form of a reusable silicon block designed for ease of integration into SoCs. Calyptra provides transparency and consistency of the root of trust. The root of trust is an important element in secure devices. The root of trust provides a set of foundational security properties that underpins higher level security features. This foundation gives workloads integrity assurances of the hardware underneath. At its core, the Calyptra root of trust takes cryptographic measurements of an SOC security state. These measurements, along with Calyptra's endorsement, can be used to verify the trustworthiness of an SOC. Security leaders from AMD, Google, Microsoft, and NVIDIA have come together to form Calyptra and provide transparency and consistency of the root of trust. Aligned on the vision that transparency builds towards stronger security and consistency creates a healthier ecosystem that the industry can benefit from. We're open sourcing Calyptra and invite the community to get involved and help build a more secure future. So Calyptra has 3 key components. The first are the specifications describing Calyptra's architecture and Calyptra's integration into secure devices. The second is the RTL that composes Calyptra and forms the reusable block that can be synthesized into SOCs. And the third component is the firmware that runs on Calyptra. It's written entirely in Rust. It gets measured by Calyptra's hardware and forms part of Calyptra's identity. Now, Calyptra transcends hardware and software. And to bring those communities together, the Open Compute and Chips Alliance have come together to support Calyptra. And as such, the specifications that describe Calyptra's architecture are being made available through Open Compute. The RTL and the firmware that composes Calyptra is being set up in Chips Alliance. Calyptra is another example of how Open Compute and the Linux Foundation are working to serve communities across the vertical integration of hardware and software. For more information on Calyptra, you can scan the QR code and come see our talk on Thursday in the security track. There will be demos in the expo hall of Calyptra at the Microsoft booth. You can also reach out to members of the Calyptra team at AMD, Google, Microsoft, or NVIDIA. And with that, I want to thank you all. I hope you have a wonderful summit, and I'm going to hand you back to Zaid. Thank you very much.
Thank you very much. Thank you very much, Brian. Now, to continue expanding on our theme today on confidential compute for our customers, we are introducing today Hydra. Hydra? What is Hydra? Hydra is a new baseboard management controller in partnership with Nuvoton. A BMC, as we all know, is a diagnostic and recovery controller which has special privileged hardware interfaces for acquiring debug data and telemetry from CPUs and GPUs. These interfaces present security concerns as they are targets for attacks that bypass conventional security defenses. As threat models evolve to restrict admins with physical access to hardware, the BMC needs security properties to establish secure links to an external root of trust. Microsoft collaborated with Nuvoton to design a new security-focused BMC with enhanced hardware security throughout the BMC SoC. The silicon-integrated root of trust supports identity flows with hardware engines for fast cryptographic operations and hardware-managed keys. The root of trust has a one-way bridge for activity monitoring and controlling the BMC security configuration, including which internal security peripherals the BMC can access. This unique feature allows the fine-grained BMC interface authorization, enabling various scenarios where temporary access to a debug interface can be granted to the BMC only after it attests its trustworthiness. Hydra has fully open-sourced firmware running OpenBMC, the Cerberus root of trust, and integrates TPM functionality. Another demo that you're welcome to see at our booth later on today. Now, as we step our foot deeper into confidential compute, seems like that's a common theme we're having today, we are discovering that a standard hardware security module such as TPM is susceptible to an attack. A discrete TPM is a chip typically used to protect secrets for the software running on various CPUs and conditionally released based on the CPU's boot measurements. Historically, the bus between the CPU and TPM is susceptible to an attack from physical adversaries wishing to falsify attested measurements or obtain TPM-bound secrets. In our approach to multi-layered security across our data centers, infrastructure, and operations, we believe in defense in depth, and that all interconnects should be cryptographically secured from from interposer-based type attacks. In partnership with Google, Infineon, and Intel, we are announcing today Project Kirkland at OCP. Project Kirkland demonstrates how using firmware-only updates to the TPM stack and CPU root of trust, the interconnect between the TPU and the CPU, TPM and CPU, sorry, can be secured in a way that prevents substitution attacks, interposing, and eavesdropping. We are open sourcing this methodology and plan to standardize this approach while working with other TPM manufacturers to adopt the same methodology so that these techniques become available to all. Now let's shift gears to a bit on scaling infrastructure. We have been observing a unique shift in the world of AI and high-performance compute. There are a number of accelerator-based solutions that you've heard of today even for AI, video codecs, and various other types of accelerators. But all these various solutions are built as commonly as separate discrete systems. When these systems are deployed at scale inside data centers, they become super complex to manage and costly to maintain. What is interesting about these accelerator cards is that they have so much commonality. When we looked at these common aspects, such as form factor, power, and management interfaces, we realized that there's a need for a converged design that brings these form factor, power, and management interfaces into a flexible modular design. So today, we announce our contribution of Mount Shasta, a modular chassis that enables multiple accelerators to fit into a single chassis supporting 48-volt power feed. And we designed this in partnership with our friends at Quanta and Molex. Mount Shasta is designed to be fully compatible with OpenRack v3, which you heard about earlier today, with a modular form factor that provides support for high-power devices and hot swappable modules with flexibility in changing module-to-module connectivity. Mount Shasta also supports additional flexibility by connecting external host chassis, and you're welcome to see this in the demo booth today after this keynote. The first virtual I/O virtualization specification was called Single Root I/O Virtualization, or SRIOV. It was released probably more than a decade ago, and conceived for the virtualized environment of that time. Generally, fewer than like 20 virtualized workloads per server, right? Pretty small compared to what we do now. SRIOV loaded sort of all of this into virtualization and management logic into PCI devices. We just increased device complexity and reduced the I/O management flexibility of the virtualization stack. So over time, CPU counts grew, virtualization stacks matured, and container and microservices technology exponentially increased workload density. As we transition now from enterprise-scale virtualized environment to hyperscale virtualization, it's clear that I/O virtualization must evolve as well. In cloud environments, I/O devices, including network adapters, GPUs, and storage controllers, are shared among many virtualized workloads requiring their services. Now, hardware-assisted I/O virtualization technologies enable efficient routing of I/O traffic from these workloads through the virtualization software stack to the devices. It helps keep overhead low and performance really close to the bare metal speeds. Earlier this year, we collaborated with Intel and contributed SIOV specification to OCP that will enable device and platform manufacturers access to an industry standard for hyperscale virtualization of PCIe Express and Compute Express link devices in cloud. This enables more sort of scalable, efficient, and cost-effective hardware designs for data centers. Now, to conclude, I would like to say that Microsoft continues to believe that collaboration through open source community engagement and industry partnership makes technology advancement more rigorous, faster, and just better for the world. We are looking forward to the continued partnership to enable innovation, scalability, efficiency, and sustainability for the data center infrastructures of the future. And please visit our booths and various engineering workshops. We have multiple talks, exact talks, and learn about our contributions. Feel free to talk to anyone, and I really hope to see you all there. Thank you, everyone.